midpoint theorem, right? And now we have, and then there are two questions left. Then two chapters are left now. One is rational numbers, and another one is uh, so-called midpoint. Sorry, Pythagoras theorem. Okay. And chemistry, may we have done this atomic structure we were studying, na? So what we studied in atomic structure? Atomic structure में नहीं, फिर हमने कल एक फिगर बनाया था, तो उसमें ये था कि एटम इज हैविंग ए न्यूक्लियस. दिस इज ए न्यूक्लियस, राइट? न्यूक्लियस which contains protons, right? And there are equal number of neutrons are also there. Neutrons are there, right? They are, and there are in different energy shells outside nucleus. These are energy shells. In outside nucleus there are these are energy shells, right? In which electrons are revolving, right? When an object is revolving in a fixed energy shell, there is no loss of energy, right? And in first orbit, first shell there is two electrons. In second shell uh, uh, there were eight electrons, right? And uh, yeah, this is eight we have. So first shell we have two electrons, second shell we have eight electrons, third shell we have 18 electrons, right? But 18 is a different method, right? So I'll say this one. This is an electronic configuration. This is electronic configuration of sodium. This is electronic configuration of sodium, है ना? This is electronic configuration of sodium, right? This is electronic configuration of sodium, and as I told you, as you told me that these are the protons, right? They were positively charged, having a charge of 1.6 into 10 to the power minus 19 coulomb, and having a mass is 1.6 into 10 to the power minus 27 kg, right? And another one, these are you know these are neutrons. They are electrically neutral, neutral, right? And they have and their mass equal to proton, equal to same word, almost equal to proton. Proton. They are not having electrically neutral. Their mass is also 1.6 into 10 to the power minus 27 g, right? They all together known as They are all together known as nucleons. Nucleons, right? Nucleons. And after that, this is, you know, this we have, this we have electrons, 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 negatively charged, negatively charged, right? Revolve in, revolve, revolve in different energy shells. Sorry, uh, different, different energy shells, energy shells around nucleus, around nucleus, right? They have charge of, negative charge of 1.6 into 10 की power minus 19 coulomb, right? And they have mass of 9.1 into 10 की power minus how much? They have 10 की power minus 31 kg, right? So this is a structure of an. This is basically structure of an atom, which we discussed from last 2 days, right? Structure, structure of an atom of element, right? Here we reached with the help of Dalton's Dalton atomic theory. After that, we gone through the work of J.J. Thomson, Goldstein, Chadwick, and then we have William Crookes. William Crookes and J.J. Thomson together discover proton, right? And then we go through with Rutherford sulfur scattering model, and then with Neil Bohr. Chadwick gave you about neutron, but Neil Bohr gave you the concept of this electrons revolving in a fixed energy shell, and he said that he said that if any object moves in a fixed energy shell, there is no loss of energy, right? So this much we studied about atomic structure. I hope you learned this much, and without any half you can you understand this atomic structure, huh? Okay, this was the revision of yesterday's class. Should I rub this? Yeah, take your time, take your time. If you're writing this good, it seems good that you're writing. You're done. Okay. Now we come to the mathematics part, which I decided to study. That is, we are going to study about rational numbers, right? We will go through with rational numbers. Do you have an idea what is rational number? Okay, anyway, can you tell me rational number? Right, you forget about this. Can you tell me how many types of number you know? Very common number is, yeah. Oh my god, real number. Oh my god, you forget about real number. First, I hope you had about You heard about natural number, right? You have heard about natural number. Then natural number means counting numbers, right? Counting numbers. And then we have whole numbers. What is that? Whole number. Whole number. मतलब zero plus counting number. Counting numbers. Numbers. Right. Then we have integers. Integers. Right. Integers is numbers. Numbers with plus or plus or minus sign, right? Minus sign. Then we have, you also heard about few more numbers, like prime. Uh, please, please stop that letter. Prime number. Do you know what is real number? You're talking about real number. What is not real number? So prime number. Yeah, prime number means uh, number divisible by itself. Number divisible by divisible by divisible by itself, right? And counter is composite number. Then we have even numbers, even and odd numbers, right? I hope you heard about this. Even and odd numbers. These are many types of numbers you studied in your previous classes. Now we are going to divide numbers. Now we are going to divide numbers in two parts. Numbers in numbers in two parts. One is terminating numbers. Terminating numbers. What is it? Terminating numbers. Terminating numbers means like 24 divided by 3. You get it? No reminder. No remainder. Right? Means Rx is equal to 0. Right? Exactly divisible. Getting? Hello? You're getting me? Now, if I write 105 divided by 15, how much you get? 7, right? So these are terminating numbers. First range is terminating numbers. Another one is non-terminating. 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 Non-terminating numbers means Rx is not equal to 0, right? They are again of two types. One is recurring number, sorry, repeating numbers. मतलब non-terminating, repeating, non-terminating, repeating numbers, non-terminating, repeating numbers, right? They are also known as recurring numbers. Recurring numbers, right? Recurring numbers. And after that we have non-terminating and non-repeating. Non-repeating. मतलब neither they are terminating, neither repeating, right? This non-terminating and repeating numbers, if you find the value of root 2, so it is non-terminating, 1.414 and keep on going, right? This is, and if I say to divide 1 by 3, if you divide 1 by 3, then what happens? If you divide 1 by 3, then what happens? You get 0.333 up to n numbers of time. You can take a bar here, you can write it 0.3 bar, right? There will be one repeating number. If I say to divide 1 upon 7, then what? How much you get? When you divide this 1 by 7, then you get 0.071 the 7, you get 3.074 the 28, we get 2.072 the 14, we get 6.078 the 56, we get 4.075 the 35, you get 5.077 the, yeah, 7 5 the, there must be 7 5 the, there must be 7 5 the, then 7 7 the 49, you get 1, again the same series will start, right? So it will be 0.14287 bar, right? They keep on repeating, right? So these types of number we have, you know. So if I rub all this, if I rub all this, you know, then you see, you know, terminating numbers, these terminating numbers and recurring numbers, right? These are recurring numbers, but non-terminating repeating numbers and terminating numbers, they are known as rational numbers, right? Rational number. Are you with me? Rational numbers, right? And this is known as irrational number. Non-terminating, non-repeating, known as irrational number, right? And these all this rational number and this irrational number all together form real number, right? What you was talking about, right? So this is real number. No, they are comes under real number. And yeah, they are rational number also. Suppose you have 3, right? We can put 1 in denominator. If we put in denominator, then value is not going to be changed. So we can put 1 in denominator of any number, and then it turns to be rational number. So that's why any number is rational number. If we put 1 in denominator, by or you we can say that in putting denominator of a number, it turns to be rational number, right? Should I do this? Okay. So we come to know that so by this all exercise we come to final definition of what is the definition of rational number. Definition of rational number is rational number if if a number if a number can be written can be written in the form of if a number can be written in the form of P upon Q, right? Where where Q is not equal to 0 and P and Q should not have should not have should not have common other than 1 other than other than 1, right? known as known as rational rational number, right? So what is rational number? If a number can be written in the form of P upon Q, where Q is not equal to 0 and P and Q should not have common other than 1, known as rational number. I hope now rational number is clear to you to some extent, right? I hope I told you all aspects of rational number. Okay, okay. Wait for a while. I'm teaching, please. Yeah. Yeah. Okay, back. Should I rub this? Should I rub all this? This one you're writing. Okay, fine. Fine. You can write it down. Huh? Should I repeat the things? Okay. I hope you have done. Okay. Now, without division, without without actual division, actual division, division, how you come, how you come to know that a number is terminating or recurring, right? Recurring. Without actual division, how you come to know that a number is terminating or recurring? So for that, rational number is equal to P upon Q, right? Right? P upon Q, where 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 Q is not equal to 0, right? Now if Q is equal to 2 raised to the power m into 5 raised to the power n, right? If Q can be written in the form of 2 raised to the power m into 5 raised to the power n, where m and n are positive integers, right? Where m and n are positive integers, right? Then it is what? It is terminating number. Terminating number, right? Then it is terminating number. If Q can be written in the form of 2 raised to the power m into 5 raised to the power n, then it is terminating number. If you need example, so if I say uh, 31625 divided by 8, 3125, 3125, right, divided by 8. So this is what? This is P, this is Q, right? And Q, sorry, Q is equal to 8 is equal to 2 raised 8, so we can write it 2 raised to the power 3 into 5 raised to the power 0, right? So why 0? 5 raised to the power 0 is equal to 1. A raised to the power 0 is equal to 1. So 5 raised to the power. So 2 and 5 are in the power of m and n. 2 can be 8 can be written in the form of 2 raised to the power m into 5 raised to the power n. Therefore, terminating, right? Therefore, terminating. Another number, if you want, which number you like most? Huh? 3 will not go. No. These are exceptional parts, they are 9 by 3 is exceptional, right? Yeah, 3 by 9 is 1 upon 3 and that is non-terminating. But the 1 upon 3, 3 upon 9 is 1 upon 3, it is a terminating number, it is a recurring number, right? If we take one more example for this is, we can call it what we call, say, 225 divided by 50, right? So here again, logic is same. This is P, this is Q, right? And what is Q? Q is Q is 50. 50 means if we do the factors, then 5 into 5 into 2. So we can write 5 raised to the power 2 into 2 raised to the power 1, or we can write 2 raised to the power 1 into 5 raised to the power 2. So they are also in the form of 2 and 5. So in this case, to find out whether it is terminating or recurring, for that purpose, if it is not, if it is in the form of 2 raised to the power m into 5 raised to the power n, then it is terminating. For terminating condition, it is necessary, right? For terminating condition, for terminating conditions, terminating numbers, it is necessary that q should be in the form of q. You understand the denominator in your in your logical thinking, that q, p upon q is a fraction where q is in denominator, and q can be written in the form of 2 raised to the power m into 5 raised to the power n, right? Then it is terminating. I hope you understand well. This much you understand well. Okay. We are not doing actual division. We are not doing actual division, right? If I, right, should I rub this examples and all? You have done. Oh my God, very slow. Anyway. No. Okay. So now this is, if now condition is something like this. Now condition is changed. What change is there? It's a just little change in condition, right? What is? As you know that p is in the form of rational number is p upon q, where q is not equal to 0, and if q is written 2 raised to the power m into 5 raised to the power n into a raised to the power p into b raised to the power q, right? A is any rational number, any number, and its power is any number, right? Then what happens? If if yeah, if you know, if q is in the form of 2 raised to the power n into 5 raised to the power n, and a raised to the power p and b raised to the power q, right? In that case, it is it is recurring number. It is recurring number, right? Recurring, uh, recurring numbers, right? Recurring numbers. Yeah. Where I wrote equal p, I wrote a raised to the power p. Oh my God! No, 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 not at all, not at all. Here q means power is different. Okay, I take it back. You can say a raised to the power p and b raised to the power s. Is it okay now? Confusion is gone. This is the power. They are two different things. They were two. But anyway, if I'm using, oh sorry, I should not take here also p, because p I am also using there. You get confused. Anyone can get confused. So we take r. A raised to the power r, b raised to the power s. Then it is recurring. I hope you understand. Uh, if you understand this, okay. So now your question is there. If I take 3 upon 9, right? So what happens? Q is equal to 9, right? We can write 3 raised to the power 2 into 2 raised to the power 0 into 5 raised to the power 0. Is it okay? So that's why it is recurring. Yeah, recurring. Got it? Any other number you have in your mind? Oh my God. 5 upon 2 will be what, man? 5 upon 2 means q is equal to 2 raised to the power 1 into 5 raised to the power 0. So it is terminating. Terminating. Okay? So can you give me some other number? Terminating. I need recurring numbers. You do not know any recurring numbers. Very bad. Situation is very. Hey, I already did that. You, you, it means you are not enjoying studies. Now I'm not teaching well. I'm not a good teacher, man. Anyway, but I'll try to do good. If you take 369 upon 17, fine. I do not know what it is, right? So Q is 17 raised to the power 1 into 2 raised to the power 0 into 5 raised to the power 0. So what it becomes? Except 2 and 5, it is having 17 also. So it is recurring, na? So this is recurring. So this is the recurring number. So recurring number is like that. Recurring number, right? Other you was talking about 1/7. That I already done. So what I do that in that 1/7, 1/3. They all people know. In examples we have done. This is something new, other than example. So I hope you understand that without doing actual division, how we can come to know whether it is terminating or recurring. I hope it is clear to you. 3. Should I rub? Now, you know one thing. Rational number plus rational number plus rational number is rational number, right? Rational number plus rational number is rational number. Getting? Rational number plus irrational number is equal to irrational number, right? Irrational number plus rational number is equal to irrational number, and irrational number plus irrational number, what happens? Maybe rational, maybe irrational, right? Right? No. If I add, this 2 plus root 3 is what? Irrational number, plus 4 minus root 3 is what? This is also a rational number. This is also a rational number. When we add these two, then we get 2 plus root 3 plus 4 minus root 3, right? This plus minus root 3 cancelled out, you get 2 plus 6. So 6 is rational. So what happens? When you added two irrational numbers, you get a rational number, right? If you take root 2 plus root 3, right, plus root 7 plus root 3, then what you get? This is also a rational number, irrational number. This is also a rational number. So you get root 2 plus root 3 plus root 7 plus root 3, right? So they together comes together, so we can write root 2 plus 2 root 3 plus root 7, right? This is what? This is irrational, right? So this is rational number. So this is not compulsory. If two irrational numbers are added together, we get a rational number, we get a irrational number. Probability is, we cannot say, right? It depends upon solving. I hope you understand. Better understand. Okay. Now, if I say rational number into rational number is equal to what? Rational. Rational number 1 into rational number into rational number. There is no need to do numbering as such. I did. That is not required. Rational number into rational number becomes rational number, right? And rational number, say, if I say 2 into 3 is equal to 6. 2 is a rational number, 3 is a rational number, multiplication is 6. This is also a rational number, right? Now rational number into irrational number becomes irrational number, right? So what you do? You can write 5 into root 2 becomes 5 root 2. This is a rational number, sorry, irrational number, right? Now, if you do irrational number into rational number, then what you get? Again, you get the irrational number, right? If you take root 7 into 3, then you get 3 root 7. So this is also a rational number. I hope you are convinced with me. Huh? Okay, very good. Very good. Don't rely on me. Irrational number into irrational number. Then what happens? Sure. Irrational number into irrational number is rational number. That's it. Okay, fine. Root 2 into root 2 is 2. It is rational number, right? Rational. No. You said rational number, so I said rational. Two rational numbers are multiplied, it is a rational number. Arna said this, right? But if root 2 into root 3, then what do you get, man? Root 6. Root 6 is what? So your Dalton's, like Dalton's, your theory is also wrong. It is rational number. Sorry, this is no, irrational number. This is irrational number. So irrational number into irrational number, there is probability of getting rational number or getting irrational. Both, right? One more thing is very important. This if two, so this much you understand. This much we have written all this. Can I rub this time? Okay. Okay. So if two irrational numbers multiplied we get rational or irrational number, right? This is clear to from here, right? But on multiplying two rational numbers, two rational numbers, on multiplying two rational numbers, no, sorry, on multiplying two irrational numbers, sorry, I'm very sorry, on multiplying two irrational numbers, and product is rational, then each number is rationalization factor of other, right? Right? On multiplying two irrational number and the product is rational, then each number is rationalization factor of each other, right? If I write like 4 root 5 plus root 3 into root 5 minus root 3, right? So by completing the square method, uh, sorry, by difference of two squares, right? Root 5 whole square minus root 3 whole square. When we take whole square, then root will remove, then 5 minus 3 is equal to 2. So they are they are irrational numbers, right? And this is what? This is rational number. So product of two irrational number is a rational. In this case, they are rationalization factor of each other, right? Uh, you know, uh, root 5 plus 3, root 5 plus root 3, and root 5 minus root 3 will be rationalization factor of each other, right? Rationalization factor of each other, and uh, this concept is known as, right? This concept is known as this concept is this concept known as rationalization. I hope you understand this. What I said. What I said. What is rationalization?